All right, so thinking back to yesterday, a reflection is a mirrored image. It's a mirrored image. All right, your first bullet point for what is a reflection. Oh, let me share my screen. Thank you. Share screen. Okay, there we go. Is that better? Okay. Okay, side conversations. A reflection is a flip. It flips over a line of reflection to create a new image. So notice the FL is highlighted and the word flip because reflections are a flip. Okay? Reflections are a flip. Something else you need to know is that each point of the figure is the same distance from the line of reflection on the opposite side.
Did you write this on the...
Another bullet point? Yes. Remember yesterday we were using patty paper to flip, but I also told you you could count how far it is from that x-axis or the y-axis and go the same number of spaces on the other side. That's what that second bullet point is. It has to be the same distance from the line of reflection. And for us in 8th grade, our line of reflection will always be either the x-axis or the y-axis. All right. Oh, okay. Okay. All right, so next we want to identify some lines of reflection. If I look at this first figure that's in our notes, where is the line of reflection? In the first figure. That's the y-axis. Yes. So the first line of reflection here is the y-axis. Excuse me, I need side conversations to stop, please. Oh, whoops, let me erase that. I wrote the wrong thing. Y'all are distracting me with all this side conversation. I'm going to blame y'all. All right, there we go, y-axis. What about in the second figure? The second figure, my line of reflection is the x-axis. And we know that that's the line of reflection because from one figure to the other, that is the axis we are flipping across. That is the axis we are flipping across. But let's look at it. All right, we have ordered pair. A is reflected across the x-axis to make point A prime. What is the ordered pair for A? 2, 3. What is the ordered pair for A prime? 2, negative 3. That's a negative. And if we remember yesterday when we were making the rules, when I look at my coordinates, what's happening to my x coordinate points? They stay the same. If I'm flipping on the x coordinate stays the same. What happens to the y? It changes to its opposite. And I know it visually looks like negative y, but we say opposite, because if I started with a negative y coordinate, then it would go to the opposite, the positive. Okay? All right, next one. B is reflected across the y-axis. Well, what's the ordered pair for B?
2, 3.
B is positive 2, positive 3. What about B prime?
And negative 2, 3.
Negative 2, positive 3. This one's just the opposite. If the y-axis is what we're reflecting, what happens to my y-coordinate?
It becomes opposite.
The y-coordinate? Look up there. If I'm reflecting across the y stays the same. The x-coordinate becomes the opposite. Remember, if you say its name, it stays the same. Yes, I just rhymed that. All right. This one is in your notes. They want us to reflect the figure shown over the y-axis. That's what they want us to do first. Then they want us to record the coordinates of the image and pre-image. So if we're reflecting over the y, good strategy, highlight that so we know that's what we're reflecting over. Another good strategy is to take and draw your arrow. I'm starting here, and I'm going across my y-axis. I had people last period, they're like, oh, I don't need to draw that little arrow. But guess what happened? They flipped it the wrong way. They flipped it vertically, thinking y being vertical. But we're going across that y-axis. All right, here's where you have a choice. You can use patty paper like we did yesterday, if you have patty paper at home, or I have some up here in the box on top of the projector. We recycle patty paper, we just keep reusing it. Or you can do the counting method. I'm going to practice the counting method, that way you can see it on my screen. But if you want to use patty paper, you're more than welcome. All right, so to practice the counting method, I need to reflect this. And remember on that the bullet point, we said that every point should be the same distance, right? So that means if I'm going to start here at W, how far away is W from that line of reflection? It is 1, 2 points away. So how far does it have to be away on the other side? 2 points. So 1, 2. So here is W prime. Plot it. Now let's do the same thing for X. X is how many spaces away? 7. 1, 2, 3, 4, 5, 6, 7. So how far does it have to be on the other side? 7. 1, 2, 3, 4, 5, 6, 7. Plot it and label it X prime. And then we have to do the same thing for Y. Y is how many spaces away? So I have to go on the other side. How many spaces? 2. So that is Y prime. Now I could put, oh wait, I didn't.
Yeah, you did something wrong.
It didn't put the point. There we go. All right. So we could connect them. Does that look like a mirror image? Absolutely. Did my size change?
No.
No. Did my orientation change? Yes, that did change. It's not facing the same way. Orientation is how you look at it. And did it move? The orientation is different. It flipped. Okay? All right, so now they want us to write the ordered pairs. So we've got W, X, and Y of the pre-image. What is the ordered pair for W? 2, 6. Very good. What is the ordered pair for W prime? Yes, we had to go to the other side. My X had to go to the opposite, so -2, 6. Y stayed the same. All right, what about X? What is X ordered pair? 7, 4. What is X prime? -7, 4. Very good. All right, what about Y? 2, 2. And then Y prime becomes -2, 2. All right, now I need to write the rule. If we're reflecting across the y-axis, which coordinate stays the same? The y coordinate. Remember, that means the y stays the same. X becomes the opposite. This right here is our rule. Algebraic representation, that's our mathematical rule. Tells us mathematically the y value stayed the same, the x value became its opposite. Any questions? What questions do we have so far? That's okay. Could I, if I was really good with the rules, could I have wrote my rules and then plotted? I could have done that too. But we did the reflecting first because that's what it asked us to do. Yes, question? Bottom left is negative. Well, this would be my ordered pair would be a -x and a -y. Because I'm going negative this way and I'm going negative this way. Because look, these numbers are negative and then these numbers are negative. Okay? All right, next one, I want you to try it on your own. Okay, so once you have yours reflected across the x-axis, remember I drew this arrow to make sure I'm going across the correct axis. My line of reflection across the x. Your figure should look like this in quadrant 1. How did we do on reflecting? Good, I see a lot of thumbs up. All right, so now we have to write our ordered pairs. D. What is the ordered pair for the original D point? Yes. D. I think you were looking at F prime. The original D. Help her out. Help him out. Okay, do you see that? When we started the origin, we went over to, down to D. So it would be 2, -2. Now, what would D prime be across the x-axis? Yes. 2, 2. All right, what about E? Ordered pair E, the original E. 7, -7. Very good. What about E prime? E prime would actually be 7, 7. Because we got to go straight up. Yeah, F prime is 2, 7. You may have just put them in different orders.
Wait, I put G on them. What am I mixing up? I'm mixing up already.
You may have put them in different orders in the table.
No,
That's
I
fine.
put G on my paper.
All right, what about the original F? What did y'all get? The original F, what did you get again? 2, -7. And then, so F prime would become 2, 7. All right, we're writing it algebraically. The rule for crossing the x-axis, what stays the same? The x stays the same. What happens to the y? It changes opposite y. Changes opposite y. All right, this was not in your notes, but I want to talk about it. Oh wait, this is in your notes. Sorry, I was a page ahead. So if we are reflecting over the y-axis, remember our rule, the y stays the same, the x becomes the opposite. You might want to make that little note in blue somewhere on your paper. Here are our rules. Over the y-axis, there's the rule. If you say its name, it stays the same. Y-axis, y stays the same. X becomes the opposite. Same thing if you are reflecting over the x-axis. Your rule tells you that x stays the same and y is the opposite. X stays the same and y is the opposite. All right. This, what is it reflected across? What is our line of reflection? The x-axis. So what is my rule going to be? X opposite y. Very good. What is my line of symmetry here? The y-axis. Did you notice I said line of symmetry instead of line of reflection? They mean the same thing. So it is the y-axis. So what's going to be my rule? Opposite x, y stays the same. What about this one? It is crossing over the x. They just overlap. That one point overlaps because the entire triangle is not only in one quadrant. It kind of dips up to the other quadrant. So when it flips, that one point goes to the opposite. So if it is reflecting over the x, what is the rule? X opposite y. Very good. All right, now it's your time to shine. We are going to make ordered pairs. Let's remind ourselves, what was the rule for the x reflecting across the x? Yes, x opposite y. And what about when we're reflecting over the y? Opposite x, y. So those rules can help you with trying to figure out what are going to be your new order pairs. What is a over the x-axis? What is it? 6, -8. What is a over the y-axis? No, a, still over the y. -6, 8. Very good. What about b over the x? -5, -1. Yes, not right now though. What is b over the y-axis? 5, 1. What is c over the x-axis? 10 and 9. I like that. That 9 was negative to start with, but opposite makes it a positive. What is c over the y-axis? -10, -9. What is d over the x? -4, 11. X stays the same. Y is the opposite. What is d over the y-axis? 4, -11. What is e over the x? Good, y'all are rocking this out. And then e over the y? -7, 12. Whoops, I wrote -12. Look at that. Good thing we have erasers. -7, 12. All right, please make sure you get this glued in to your notes. And then I will pass out your homework. Those of you online, your homework is online.